Okay, everybody. Moving on from oil, now we're going to move into that other category of energy. All that other stuff that move away from the conventional fossil fuels that we're used to. Now, when I'm talking about alternative and this other group, keep in mind that this group of energy sources is constantly growing and the information associated with these forms of energy is constantly changing. You could have an entire class, you could have an entire unit on alternative energy use. Unfortunately, in the absence of time, we're going to cover these alternatives in one lecture. Before we begin, I want to show you the diversity of those alternatives, and I want you to go ahead and listen to this NPR story. This NPR story is interesting because it looks at harnessing energy from a source that we often overthink, but at the same time is a very valid source of energy. However, as you'll see in the story, there are some hurdles to overcome with tapping into such energy sources. Let's take a look at nuclear energy. Of all the alternatives of energy out there, nuclear is probably one of the most controversial and one of the most misunderstood. Nuclear energy comes from splitting atoms. Splitting these atoms it produces a reaction to where heat is released. It's an exothermic reaction. Now you're splitting atoms very much in the same way that you're creating a nuclear bomb explosion. With that said, there's a big difference between the type of fuel that's used in a nuclear reactor versus the type of material that's used in a bomb. What's very interesting with nuclear energy, though, is even though you have this very complex and very modern look at physics and chemistry and you name it, what it comes down to is the heat that's released from this reaction right here is no different than the heat that's released from burning coal. And the way that that heat is used to produce energy is the exact same way that we use the energy from burning coal. That heat is used to heat up water to turn steam turbines that then turn the electromagnetic generators. It's somewhat primitive, and this is where nuclear power has a long way to go because of the fact that you have such a modern form of creation of energy and so much is lost in what we're doing. Now, I should also point out that a very coveted form of using nuclear energy that would not produce the waste that we have right now from splitting these atoms is that if we were able to fuse material together or nuclear fusion, you would have a much more stable, much more controlled reaction. However, that is theoretical right now. This is another story I'd like you to listen to. This is a story that relates to what's going on with 3 Mile Island, where they just went up to renew their lease. 3 Mile Island was in the news uh, before many of you in the class were born. Uh, this is what this is what led to a backlash of nuclear power within the United States. Of course, this was followed up in 1986 by Chernobyl in the Soviet Union, and nuclear power to that till then really suffered. And then, of course, we had the most recent events in Japan. Prior to what happened in Japan, nuclear power was actually seeing a rise in terms of public acceptance. Where nuclear power is going remains open, but I'd like you to listen to this story and get some information behind nuclear power and what went on in this incident at 3 Mile Island. If we take a look at nuclear power generation, we can see that we have a few regions of nuclear power generation. Within Wisconsin, I often find it interesting when I talk to people who are very frightened by nuclear power, who don't even realize that we have several nuclear power facilities in very close proximity to us. Nuclear power is something that lots of people are very afraid of, but at the same time, many people don't realize, unless it is very close to them, that it's something that's going on very close to where they live. Of course, we have quite a bit tapping into the water associated with the Great Lakes and the Mississippi River. And then we also have quite a bit of nuclear power generation over here in the Mid-Atlantic region, with a few nuclear power generation stations hit or miss throughout the rest of the country. If we take a look at this map's interesting because this gets into if people are very worried about nuclear power, and whenever there's talks of putting up a new reactor, there's a huge backlash saying that I don't want to be impacted. But what people don't realize is that oftentimes you are well within the range of if there was an incident of a nuclear power problem, you are within that range. Nuclear power, the newer reactors are much different than the older reactors. I would encourage you, if you're either for or against nuclear power, to look into this issue more, as a modern nuclear reactor is very different than the nuclear reactors that you saw in the incidences in Chernobyl and even in Japan. New reactors are gravity fed. They have multiple fail-safe systems within them. This is just another map showing you that distribution. Now, what are the risks? The risks associated with nuclear power is a failure of the cooling system. If that cooling system fails, if the pumps to generate that power to the fueling system fail, such as what we saw in Japan, that reactor has a tendency, or not a tendency, will heat up. And what you could have is you could have that thing heat up to where you have a release of radioactive steam into the atmosphere, as you saw in Japan and within Chernobyl. Now, when you have a cooling system that operates on a pump from an external power source, this is the problem that you run into. However, the newer pumps are gravity fed in that they're above this system and they run down within. There is that issue. There's a very good book out there called The World Without Us. In that book, they explore what would happen with these facilities, and one of the biggest worries out there is something along these lines, in that if we start looking at potential instances in the world with nuclear power, in terms of if, to use the show The Walking Dead, if we had a zombie apocalypse, zombies really wouldn't be what you would want to worry about too much. It would be the failure of these nuclear power generators, in that most nuclear power generators have backup power available for about a month. And after that, you're going to start losing your power source and you're going to have some problems. Now, are we ever going to have a zombie apocalypse? Probably not. But at the same time, there are theoretical situations, as we saw at Japan, to where we could have instances in localized areas to where supplying that power is not feasible. If I were to throw my opinion on this, I'm a very big proponent of nuclear power. However, I think a lot of these issues need to be explored, and they need to do a better job with public outreach and educating the public in terms of what needs to be overcome and what needs to be done with this. Nuclear power also has a waste issue. However, as we saw, when we start looking at waste, there is an issue with coal waste. Nuclear waste is a problem in this country, and where to put that nuclear waste remains an issue. There's a lot of talk of where to put this. There was a lot of talk of using places in the desert. However, the desert, as many studies have been showing, these are not the stable environments that we once thought of. So where we put this, there's been talk of putting this in former oil wells with underneath salt domes. But right now, pretty much the most conventional method is dry cask storage above ground. The storage we have now, most of it is designed to be temporary, but it's becoming more and more that it's kind of the convention. Dealing with nuclear waste is something that we have to address. Now, once again, you want to start looking into nuclear power more, because there's ways to deal with using your nuclear waste over again. Unfortunately, a lot of the nuclear waste that we produce is technically considered weapons grade, and due to some international policies that we have, using this again, you run into some issues with that. I would encourage you to look in more into nuclear power if you want to learn more about these policies. It's something that we can't cover in this lecture right now. Where to put nuclear waste? Here's yet another story I'd like you to listen to. This story deals with the issue of nuclear waste, where to put it. It talks about the current use of Yucca Mountain, but also it talks about some of the issues that we have. As I stated earlier, another alternative is salt domes. Salt domes have kept in materials as light as hydrogen for millions of years. They're a perfect seal to keep this material in. They're fairly stable geologic environments. Using a salt dome for nuclear waste is an alternative that should be explored more. The question comes up though, zombie apocalypse or not, is how dangerous is nuclear power? If we start looking at nuclear power and we start comparing this to air pollution in the 20th century, nuclear power starts to seem like a very safe bet. However, when we start looking at the instance of people dying from a nuclear power, all rapidly or acutely, versus slow accumulated deaths over the years or chronically, what we can start to see is that nuclear power pales in comparison in terms of how many deaths the use of conventional fossil fuels, predominantly coal, have cost in the world. We look at this air pollution. If we start looking at autopsy records and the types of afflictions that have hit people, you can start to look at the fact that many people, now this is not in the United States, this is around the world, many people have died from air pollution. We start looking at if we start looking at just on mining coal, 100,000 people, and this is a conservative estimate, have died mining coal within England. Now this extends way back into prior to the 1700s when the methods weren't that good, but if we were to relate this to a little bit more of a modern instance, we see 1952, you had something called the London fog. Now, the London fog is interesting because this is related to coal pollution. We compare that with asking how many people died in Chernobyl, and then we can even look at this in terms of Japan. If you're looking at this story, or if you're looking at this question, and you say the number 12,000, you are correct. 12,000 people died within several days in the London fog instance of 1952. This was directly related to coal pollution. Now, if 12,000 people died from a nuclear power instance, I can guarantee you'd hear about it quite a bit. This, though, is something that people, it's almost been swept under the rug within history. However, there is a story related to this right here that you can listen to. If we look at Chernobyl, now the numbers with Chernobyl are very much debatable. But if we start looking at the immediate deaths and then deaths within the first year or so, we can safely say about 500 people have died. Now, when we move beyond that, we start getting into a lot of debate in terms of how many people have died in Chernobyl. I would encourage you to look into this more, but at the same time, if we do start looking at nuclear power and we start looking at conventional fossil fuel power, the numbers are there in the fact that many more people have died using fossil fuels than within using nuclear power. Let's take a look at some forms of renewable energy. Now the big ones right now is wind, solar, and your green fuels or biofuels, predominantly ethanol. Now there's biodiesel and the like as well. What I'm going to tell you is to read the reading that was put into this unit related to biofuels. It's a very good overview provided by National Geographic in terms of what biofuels are out there and some of the controversies associated with those biofuels. We take a look at renewable energy. We take a look at renewable energy and we can see with photovoltaic power or solar power, we can see that you have an upward trend of use. Now, solar energy has become very cheap. We take a look at wind energy and the projected trend for this to go up. We take at ethanol, the projected trend is for this to go up. Now these are all projected trends. I can tell you right now that all these trends are holding strong right now. Let's take a look at wind energy. Wind energy, you could have 20 million megawatts of wind power if you tapped it commercially wind-wide. Now this is theoretical. However, wind has a lot of potential. That's 50 times the current amount of nuclear power generation. What would that mean? That means we could supply a good amount of the power we need in the world right now with a wind network alone. However, there are issues with wind. Right now, it doesn't operate at an efficiency that we would like. However, this efficiency is getting much, much better. Under normal conditions, the price is typically around about 5 cents per kilowatt hour. This is going down. Standard modern turbines use only 2 or 3 blades. However, there's new turbines out there that are being developed that are going to use much lighter material and more turbines or more blades on their turbines to generate even more power. This is what you have on the NPR Power Grid series, and this is a really nice map showing the potential for wind power, and you can see that we have a really nice wind power corridor right here in the United States. If you were to take a meteorology class with me, we would talk about the reasons for that, but right now just understand that the United States is unique in the world in terms of the very strong winds that we have and the potential for wind power that we have. We take a look at this map right now. This is a great map. This is a map that shows winds within the nation. I often have my weather class students take a look at this map. What this map is showing is that the wind is always blowing in one part of the country. And of course it doesn't blow all the time in other parts. You take a look at this area right here and we can see there's a dearth of winds in this area. However, there's some very strong winds down here, some very strong south winds, some very strong southwest winds over here. We have some pretty strong southwest winds here, some strong southeast winds here. Getting into the series that you want to read on the smart grid, tapping into things like wind and solar power do require in many ways the incorporation of a smart grid and a much better developed infrastructure for delivering electricity. Why? Because the wind is always blowing somewhere, but it's also not blowing in other areas. And if we are going to harness the power of wind, we need an energy grid that we can divert power from one area to another much more efficiently than what we have going on right now. Wind farms are the norm in terms of what we think of producing wind power. However, another instance of moving away from our conventional thinking when we start putting in a smart grid, if we ever do, is moving away from the concept of wind farms and instead thinking of small clusters of wind turbines in different areas of the country, predominantly on large businesses and individual entities that can afford to do it with the capital to do so. Places like Google, Microsoft, university campuses, government buildings, these are all places that have the means to put in wind power facilities. This wind power facility could supply the power to the facility when needed or when the wind was available and blowing, potentially even having enough surplus to put away into the grid. But also you have to remember that these facilities could not rely solely on wind and would have to pull in energy from elsewhere. Could be solar, it could be natural gas peaking operations when the wind was not a reliable source. Wind does have a bad reputation. It's known as a bird killer. Unfortunately, for the people that promote this, wind is not really that much of a bird killer as what is being promoted. What you have to remember that it's all relative. Yes, birds from time to time do fly into wind turbines. However, if we start looking at the numbers in terms of how many millions of birds die every year flying into household windows, and how many birds are killed daily on people's commute into work, we would start to see that the amount of birds dying from wind power is minuscule. It's less than I think it's less than 0.01% of what you have being killed on a daily basis elsewhere. No wind equals no electricity. This is true. But as we saw, the wind is always blowing in one portion of the country. When the wind isn't blowing in one place, it's definitely going to be blowing in another. And with the incorporation of a modernized smart energy grid, this would not be so much an issue. Wind power is considered to be noisy. Now, this is really dependent on the individual. On my part, I have no problem with the noise of a wind turbine. I think of it as much better than listening to the sounds of a freeway or city traffic. However, this is a factor, and when you start looking at places like the Door Peninsula in Wisconsin, you have people who have vacation homes up there. Often they're not even from this state, and they are not very big fans of wind power. They think that it's going to be noisy and ruin their vacation, and they would rather not look at it when they have their homes there. The other one is you can't replace coal, non-economical. This ties into the no wind. Right now, with the way we conventionally look at how we produce energy, yes, you cannot replace coal because coal is a base power for us. Coal is also very cheap when you start comparing it to wind. However, we have to also look at the subsidy issue in that coal is heavily subsidized. Lots of money is put into coal, especially into developing clean coal technology. This is something that if you were to level the playing field, we might not see that. Also, if we start moving away from this centralized power concept and moving more into regional power and individual power within the context of a smart grid, this might not be an argument. But however, as things stand, yes, wind could not replace coal as a substantial base load of power. Visually unpleasing, this is another one. Oftentimes when you have people who live in vacation areas who are arguing against wind power, they won't use this one. They'll rely on these other ones because it just doesn't make you sound very credible if you just say it's visually unpleasing. However, this in many ways is generational. Usually when you're dealing with older generations, they don't find wind power visually pleasing. When you start talking with younger generations, they find it very pleasing indeed. There are issues with spacing of wind power. If you take a look at this graphic, this is a graphic that shows how wind power, when you have spacing issues, this is just under the right conditions in the kind of in the North Sea in the English Channel area, is you can see that this condensed water vapor on the sea is these wind turbines are creating wind flow shadows. So when you start dealing with these wind flow shadows like that, you start to realize that when the wind is blowing, these areas downwind are not going to be getting the same amount of wind as these ones right up front. I encourage you to listen to this story as well. Moving into solar power. Solar power is the average daily solar radiation in the United States. This is 3.69 British thermal units per square foot. We take a look at this map, we see in June we have quite a bit of solar power potential in this area of the country. Of course, the northern tier of the country doesn't have as much. This is because of the amount of cloud cover affecting the northern tier of the country and the southeastern portion of the country. In December, we can see that we still have a good amount of potential in the southern United States. Now there's different types of solar power. There's passive solar energy. Passive solar energy is using solar power for heating. So if you could have a passive solar energy placed on your roof, this is what Carter had put on the roof of the White House. This was just to supply heat. You have pretty much tubes of water that are heated, that's circulated through your home, and those tubes that are heated by the sun provide heat for the house. Now you also have active solar power energy. Active solar power energy is where you're using the energy from the sun to produce electricity. So this is where you have your photovoltaic cells come into play. Your photovoltaic cells, that's taking energy from the sun and it's converting it into electricity. You can also have active energy to where you have parabolic mirrors. So you have mirrors pointed just like kind of what you would do with a magnifying glass to start a fire with one, and that those mirrors are focused on tubes. Those tubes heat up to generate steam. That steam then, of course, provides electricity. This is not as energy efficient as this by at all. However, the good part about this is that you could actually supply heat energy and you could supply electrical energy with the use of parabolic mirrors. This is an example of passive solar energy. You have a home. Of course, this home is oriented to the south, and you have all of the energy from the sun coming in and heating this home. These upper portions are venting out the heat from the home. In terms of photovoltaic solar energy, photovoltaic cells capture that solar energy and they convert it into electrical current. This technology has come a far way from 1954, when Bell Laboratories first came up with the concept. In 1958, when this was going on just within the space industry, you were talking about $2,000 per watt of energy. That's quite a bit of money. Only the military and things like NASA could afford that. By 1970, this was down to $100 a watt. In 2002, $5 a watt. Currently in 2012, we're under $1 per watt of energy. Solar energy, in terms of photovoltaic cells, has gotten so cheap that you can buy for under $100 a solar panel that can fold up and literally charge your cell phone and power your laptop. If you want to go a little less portable than that, you can start looking at very large panels that you could put on the roof of your RV, on your cabin, on your deer blind, and literally with the use of just a couple $100, you could power the televisions and lights within that small operation. In fact, if you start looking at investing even more and you have the right conditions, you could power your entire home for a fairly reasonable price. Who's driving this trend? Why is it under $1 a watt? It's not the Americans. This ties into your Friedman book. This is the Chinese. If we take a look at jobs and land required for alternative energy, there's also quite a bit of money out there and jobs out there in the alternative or new energy sources. I often encourage geography students with skills in geospatial technology to look at the expanding gas industry, but not only that, look into jobs within the wind and the photovoltaic industry, and also solar power industry. You can see from this graphic that there's quite a few jobs out there in these industries, and these are much higher paying jobs than a job you would get in the coal industry. Now, biofuels, not all biofuels are equal. You need to look at them in terms of the energy input versus the output. We take a look at some of these sources and types. This is from the National Geographic article I assigned you. I encourage you to look at that article because that article is going to talk to you about the difference in input versus output within biofuels. Of course, I also have a story for you to listen to related to this. This story relates to ethanol, and it's a very interesting story for you to listen to because there's a huge debate going on right now with ethanol in terms of how good it is for climate footprint, but also in terms of a source for us to get away from foreign oil. I'd like you to read that story and make some decisions on your own related to biofuel technology, predominantly where we're getting our ethanol from. We take a look at this. This is corn-based ethanol. There's a lot of controversy with corn-based ethanol. That's another story for you. This is from your National Geographic article, and of course, they have your input versus output ratio. I'm not going to get into this in too much detail because I'd like for you to read that article to get that information. There's an NPR series on ethanol. I'd like you to take a look at that as well, or give that a listen. And of course, we have our different sources for ethanol. It's not just from corn. We have our different biofuels. We have our biodiesel, we have our cellulosic ethanol, and we also have our cane ethanol. Finally, as a final slide, I'd like to talk to you a little bit about hydrogen. Now, hydrogen is something that you don't hear too much about anymore, but you still will hear about it from time to time. The problem with hydrogen is it's very hyped up, but it's very theoretical. It's very similar, if not a bigger hurdle to overcome than clean coal technology, in that hydrogen is extremely expensive to produce. Producing hydrogen, you need to have some type of an external fuel source to produce it. Right now, what we're producing hydrogen with is natural gas. And so logically, the argument would say, well, why don't we just use the natural gas instead of making this hydrogen? You also need room for fuel. Now, I think one of the biggest mistakes that has been done is that there's this race to power vehicles with hydrogen fuel instead of looking at hydrogen fuel from a much more stationary perspective, in that it could provide energy for a neighborhood, for a city, and even for a region. That is, if you had a way to produce the hydrogen without such a high cost and using external fossil fuels. That cost of the fuel is really high because of the cost to produce it. We also would need to develop an entire infrastructure to transport this fuel across the country, whether or not that would be a pipeline or transport in trucks. Right now, the way that it works with transporting this in fuel tankers is that you're talking about losing well over half in transit. Of course, hydrogen fuel must be better than the competition. If you're going to bring hydrogen fuel into the game, you have to have that fuel cheaper and more readily available than what we have out there. And that ties back into the issue with natural gas, in that if natural gas is very cheap and we already have a strong infrastructure for natural gas, why would we then incorporate hydrogen at this point? So that's it. I encourage you to look into many of the different topics that we went into today in more detail if you're interested. I apologize for not being able to go into these in more detail, but the world of alternative energy is so diverse and it's changing so fast that it'd be very difficult for us to do. Listen to those radio stories, read the articles associated with those stories, get to know this material. Thank you.